Hello Math 20-2, welcome back. Today we are going to be doing kind of the shortcuts to yesterday's lesson. We're going to learn how to use it on a calculator. It is important to know both because the other one really tests your understanding of what's happening. This one here is kind of tests your understanding. It's kind of a cheap, fast way to do it. So let's take a look at our first question. The reason why I'm not doing the first few pages is because those are kind of your notes on the keystrokes to do it. And here we're going to do this first few questions together. Now it says, now we're looking at a postal service here, and it says it takes 3 weeks on average for a package from China to arrive to Canada. Alright, and it also says the standard deviation of 5 days. So this is days, this is weeks. We better be doing this in days then. So the 3 weeks is the same as 21 days. Okay, so we know my mean is equal to 21. You know, my standard deviation is equal to 5. And it says right here, the question wants, what to the nearest hundredth, what package will take less than 15? We're looking at x is equal to 15. Interesting. So where is that? If I was to draw it out, my mean is 21. X is going to be that way of the mean because 21 is bigger. So 15 is going to be somewhere over here. My standard deviation is 5. I know right away it's more than one standard deviation away. And we want everything less, because it says less than will take less than 5. Alright, now we could do this and do the fancy plugin, but here we're just going to go and do this quickly on our calculator. So first of all, we're looking at normal distributions. So I'm assuming that where are we going to find this? In the distribution part of our calculator. So I'm going to put second, and see that distribution right there? Second distribution. Now, what kind of distribution is this? We're doing normal. Here we have two kind of normal distributions. In this class, we are mostly looking at, right now, a normal commutative distribution. Okay, so it's a commutative. So we're going to click on that one. And I'm going to put in here all of our things. I'm just going to delete. Okay, so first of all, my lower in this case, I have negative 99999, I went on forever. Why? Because we have no limit this way. So I put an absurdly huge negative number to know it goes on forever that way. Now what is my upper bound? My upper bound is my most right bound. My upper bound is 15 because it's everything less than 15. So I'm going to put in for my upper bound 15. My mean is 21. There's the symbol for mean. And my standard deviation is, like we said, 5. So I'm just now going to graph this, or do it. And it says right here, it wants to know the probability to the nearest hundredth. It is 0.115, which is the same as 0.12. So it's 0.12. Look how fast that was. Fast, simple, easy, not much calculation. But on the test, I'll still want you to do it the less than 5 way. Okay. Let's look at B. So B is a bit different. It says, postal outlets guarantee the package will arrive in less than 35 days. Less than 35 days, okay? Or else it is free. Last month, 0.825, or this, a lot of packages, 8,257 were sent from China to Canada. How many of these packages would you expect to be delivered free of charge? So less than 35. Or sorry, for greater than 35. So if it takes more than 35 days, it's free. We've heard stuff like that. So we have 21, 35 is here, and we want everything greater than 35. Alright, so let's go to this commutative distribution again. So where is it? Well, we got to go into our distribution. And, because it's a distribution, we're doing commutative distribution. Now, our lower limit. Do I have a lower limit? Yes. My lower limit is what? 35. My minimum is 35 days. Otherwise, it is free. So I'm going to put 35. Now, what about my upper limit? It goes on forever that way. So I'm just going to put a ridiculously high number. I just put 9 a bunch of times. Now it's going to say, what about my mean? My mean is 21. Standard deviation is 5, same as before. I push enter. And I get, and my thing is going to be equal to, enter, 0 0.00255. Okay, so 0.00225, and that goes on. 5 is the probability. All right, but it says out of this many packages, how many will be free of charge? So that's the probability. So that's like 0.2%. So I have to multiply this by that number. So I multiply that, take that answer, and I multiply it by 8257. I'm going to get 21 packages will be free. Okay. Now, if I ask, what did you punch in your calculator? You're going to put this: the normal, and normal, and we're doing CPDF or CDF. Sorry. And we're going to say 35, and the next one is and then the next one is, and then 5. So it's just the order of what you put in your calculator, so it's pretty simple to do. Okay. Now, number 2 says, calculate the percentage of the population to the nearest tenth whose height is more than 1 standard deviation above the average height. So we want who's 1 standard deviation above the average height. This one here is kind of interesting, isn't it? We know it's 1 standard deviation above the average height. Does it even matter what our average height is? No, we want to know the population above 1 standard deviation. So for this one here, oops, I didn't want to graph. So I'm going to go to my distribution again. Go right here, enter. Okay, so we want everything that is above 1 standard deviation. So in this case, I'm going to say my standard deviation is, we want my upper is 1. Okay, we're going to say my mean is 0, and my standard deviations are 1. That's my lower, because we want everything above. So if I was to graph that, this is kind of confusing. I'm going to say my mean is 0, and I want 1. Okay, because that's all it's given me. I want everything greater. So my minimum is 1, mean is 0, standard deviation 1. And my upper is infinitely big. So I'm going to push enter, 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 paste. And I'm going to end up getting 15.9%. I hope you understand that. So the next one here is they're looking at your inverse norm. So we're going to skip that and go straight to an example where we do our inverse norm. Okay? So inverse norm is the same thing as calculating a z-score given the area to the left of the z-score. Okay? So if we're given the area, how do we do that? Before, we were never given the probability. So now, when we're doing it on the calculator, in the question examples before, we weren't given the probability. We were trying to find the probability. So now what happens if you're given the probability? We have to use the inverse norm. So I'm going to clear all this right now. And I'm going to go second distribution. And we go all the way to inverse norm. So we're using this function. So here it says determine the z-score to the nearest hundredth if 1% of the data lies above the z-score. So what is my area? My area in this one is only going to be 1%. Okay? Or so my area lies above, lies above. So we look at this. My area is just this. So it's everything less is 99. So we have 99% is the area. What is my mean? Well, my mean is 0, we could say. And we want lies above the z-score. 0, and then we have our standard deviation is 1. We want 99%. Oops. I'll quickly. There was my mistake. I said 99%. Well, it's probability, so that's 0.99. Whoopsie. So we have to go back over, and it's 0.99, and 0 is 1, push enter, I'm going to end up getting, it is 2.3. So my z-score is equal to 2.3. So we are 2.3 standard deviations away. Okay? Oh, nearest hundredth, 2.33, so we round up. All right? Well, good luck with this assignment, and I'll see you tomorrow. Now remember to bring up any questions you have, because I'll be checking for questions and understanding tomorrow as we go on the assignment together. Good luck!